Assalamualaikum and good day. I am Akila Nuizati binti Kasim, along with Anis, Azura and Farhana, will present about ultrasonic testing. I will start with principle of ultrasonic testing. Ultrasonic testing UT is a non-destructive testing method entity that use high-frequency sound wave to detect flaw, defect, or measure material property in a variety of material without damaging the object or material that be tested. UT is ideally used for inspection of denser crystalline structures such as metal. Ceramic, plastic, composite, and concrete can also be successfully inspected, but with reduced resolution, since the attenuation in this material is higher. A typical pulse echo UT inspection system consists of several function units such as the pulsar or receiver, transducer, and a display device. The principle of ultrasonic testing is based on the transmission of high-frequency sound waves, typically in the range of 0.5 to 20 MHz, which are directed into the material to detect the locate internal flaw or defect. A pulsar or receiver is an electronic device that can produce high-voltage electrical pulses. Driven by the pulsar, the transducer generates high-frequency ultrasonic energy. The sound wave travels through the material until they reach an interface or boundary, such as the edges of the material, a crack, or a void. At this interface, a portion of the sound energy is reflected back from the floor surface. The reflected wave signal is transformed into an electrical signal by the transducer, because transducer contains a piezoelectric crystal that vibrates in response to the sound waves. As the crystal vibrates, it generates an electrical signal that is sent to the computer for analysis. The computer analyzes the signal to determine the time it took for the sound wave to travel through the material and reflect back to the surface. This information is used to create a visual representation of the material's internal structure. The visual representation, called a waveform or a scan, shows the location and severity of any flaw or defect in the material. The results are interpreted by a trained technician who can determine the location, size, orientation, and other features of the flaw or defect and decide whether it is acceptable or require future action. For example, a larger defect will produce a stronger reflected signal, while a deeper defect will cause a delay in the arrival time of the reflected wave. This technique is widely used in industries such as aerospace, manufacturing, and oil and gas to detect flaw or defect in material and structure. And it is a valuable tool in ensuring the safety and reliability of critical components. That's all for me. Thank you.
Hi and Assalamualaikum. My name is Nur Anizafira binti Dizol and my matrix number is 153706. Now I will start presenting my part, which is the ultrasonic testing procedure. Usually, once the pulse receiver is connected to the transducer and a diagnostic device, the process of inspection begins. There are multiple methods to carry out the ultrasonic testing, and these methods can be classified into three main categories, which are the methods of receiving ultrasound, angle of sound waves, and method of coupling. There are two methods of receiving ultrasound, which is the first, reflected transmission, and the second is through or attenuated transmission. So in the reflected transmission method, a pulse of energy is sent through the test piece and it continues until it hits a different medium, and this is usually the back wall of the piece. And after that, a reflected pulse or an echo is then emitted back from the back wall. And the intensity of the pulse and echo are noted, as this can tell us about the location of the crack or any imperfection. And in case of a crack or imperfection, the pulse will not reach the back wall and it will be reflected from the location of the imperfections and resulting in an echo signal of lower intensity. Now to the next method, which is the through or attenuated transmission. In this method, an ultrasound is sent through one surface of the test piece and is received by a separate receiver on the other side of the piece, and this can be seen from the image that I've included in the slide above. In case of imperfection, the intensity of the sound received will be lower than usual, and for this method, at least two sides of the test piece must be available, and this time is better for pinpointing the location of the crack, but the depth of which it is located can remain unclear. Next is the angle of sound waves. There are also two methods for this part, which is the first is a normal beam and the second is an angled beam. A normal beam refers to the angle at which the pulse is introduced to the test piece. A normal beam is a 90-degree angle, and the normal beam method can be used for test pieces that are flat or smooth with no unwieldy obstructions. The next method is an angled beam. So in this method, the pulse is emitted into the test piece at any angle other than 90 degrees. And for this method, an angled transducer will be required for an easier sound introduction, as you can see from the image I've included in this slide. This method is very useful when the best way to get to the largest reflection is at a diagonal angle. And it is also useful in case some part of the test piece is obstructed, and when normal beam is not possible. This method is useful for determining the thickness for the test piece and depth of the imperfection. The last part is the method of coupling. There are three methods of coupling, which is the first, contact, immersion, and non-contact. For the contact, in contact testing, a couplant is applied between the transducer and the test piece to reduce the air and increase the intensity of the sound waves. The second part is the immersion. In the immersion testing, the test piece and the transducer are both immersed in a bath. The picture of how this is conducted will be shown in the next slide. So in this type of testing, the water acts as the couplant, and the movement of the transducer is smoother in this method of ultrasonic testing. In this method, direct physical contact between the transducer and the test piece is not required. Also, a specific immersion transducer is to be used for this method. And for the last part, for the non-contact is a type of testing that does not require contact and operates on principles of electromagnetism mechanics. These are the images for the different method of coupling. Ultrasonic testing can be conducted in a variety of materials. It is applicable to massed metals, alloys, and composites, as well as concrete, ceramics, plastic, and even wood. Ultrasonic testing is even used in the medical field, such as a sonography. So I think that is all from me. Thank you so much. We will continue to the next part.
Hi, my name is Azura binti Azmi, and now I will talk about the advantages of ultrasonic testing. The first advantages is ultrasonic testing have a greater accuracy than other non-destructive methods in determining the depth of internal flows and the thickness of the part, where the detection limits are in the order of 0.1 to 0.2 mm, although smaller defects, typically 0.04 mm diameter. The second one, ultrasonic testing have high penetrating power, which allows the detection of flows deep in the part. Due to its high frequency, ultrasound has greater energy than audible sound. Therefore, the penetrating power depends on the energy of sound. The third one, the ultrasonic testing have capable of portable or highly automated operation, where it can be used to produce detailed images with automated system as it is highly portable. Next, the ultrasonic testing does not have potential head hazard, unlike radiography. There is no radiation hazard in ultrasonic examination, hence it is completely safe for humans to use and no effect on equipment and materials in the surrounding. Next, the result of ultrasonic testing is immediately. Ultrasonic testing can be performed quickly, allowing for fast and efficient testing of large volumes of materials. Last one is ultrasonic testing. It is sensitive to both surface and subsurface discontinuities. Ultrasonic testing methods are suitable for detection, identification, and size assessment for both surface. The test can be used only one side or surface of the object.
Assalamualaikum. My name is Nur Syaidatul Farhana binti Mazlan, metric number 153955. Apply Physics third year student. Today I'm going to present these advantages of the ultrasonic testing. First disadvantage of ultrasonic testing is it is required to have a skilled operator because ultrasonic testing requires a trained and skilled technician to operate the equipment and interpret the results. Improper use or misinterpretation of results can lead to inaccurate or incomplete inspections. It is because manual operation requires careful attention by experienced technicians. The transducers alert to both normal structure of some materials, tolerable anomalies, and other specimens, and to faults therein severe enough to compromise specimen integrity. These signals must be distinguished by a skilled technician, possibly requiring a follow-up with other non-destructive testing method. Next is limited penetration depth. The depth of penetration for ultrasonic waves is limited, which means the defects that located deep within a material may not be detected by the equipment. Other than that, it is equipment limitations. The quality and capabilities of the ultrasonic equipment can affect the accuracies and reliability of the inspection. Older or poorly maintained equipment may produce inaccurate or unreliable results. Next is surface preparation. Ultrasonic testing requires proper surface preparation, including cleaning and applying a coupling agent to ensure accurate and reliable results. Parts that are rough, irregular in shapes, very small or thin, or not homogeneous are difficult to inspect. It is because surface must be prepared by cleaning and removing loose scale, paint, and although paint is properly bonded to a surface needed to be removed. Next is material limitations. Ultrasonic testing may not be suitable for all materials, such as those with highly irregular surface or those that absorb or scatter ultrasonic waves. Parts that are rough, irregular in shape, very small or thin, or not homogeneous are difficult to inspect. And lastly, environment limitations. Ultrasonic testing may be limited by the environment in which it is performed, such as high temperature or noisy environment, which can interfere with the equipment or signals. In addition, expected item must be water resistant when using water-based couplants that do not contain rust inhibitors. In these cases, antifreeze liquids with inhibitors are often used.
Now, I will talk about some of the applications in ultrasonic testing. The first application is inspection of large fudge bars using a compression wave technique, as shown in the first picture. The second application is checking of circumferential welds in a large diameter pipeline, where the first picture shows that the ultrasonic inspection of pipeline weld using a shear wave probe. The third application is checking the wall thickness of a valve body in a chemical plant as a part of the routine maintenance inspection using a digital readout ultrasonic wall thickness meters, as shown in the pictures. Next, the last application is a special purpose test rig for measuring wall thickness and determine any eccentricity in hot forged steel tube. The measurement can be made when the tube surface temperature is as high as 815 degrees Celsius.
That's all from us. Thank you.